G'day fellas, and welcome to Mr. Mickleburgh's Maths World, the way it is. Now guys, when we do calculus, we're going to have to know a bit about our index laws. In particular, if we see things in surd form, we probably need to convert them to indices. Now, have a look at the first general pattern. An example of what I'm talking about would be if we had to find the derivative of, let's say, the third root of x squared. That's pretty hard to see what happens, how we do it. So we put it in index form first, and I'll certainly be doing calculus on these sort of expressions in another video, but we just want to revise our index laws for the moment. So our template is saying if we want to go from surd form to index form, and you've got an expression of this form, the rth root of a that's been raised to some power, all you do is you write down, well in this case it's x, and the power is 2 over 3. Okay? So the fractional index x to the power of 2/3 is exactly equal to the third root of x squared. Okay, here's another example of what I'm talking about in that connection. Let's have a look at the 7th root of x to the power of a half. Alright? Now, to convert it to index form so that we can differentiate it, this is what we would do. We write down the x first. Now, the power is a half, and the root is 7, isn't it? Okay? So a half divided by 7 is 1/14. Alright, so that's equal to x to the power of 1 over 14. Here's another index law you'll need to know about. If you've got an expression raised to a negative power, it really means just 1 over, in this case I'm calling it a, raised to the positive power. So very simply, here's example a, x to the power of negative 2 is just equal to 1 over x to positive 2. Alright, the negative goes to a positive. Working the other way is sometimes what we need to do. So example B might be this. 1 over x cubed, you should be able to see from our general pattern, is going to equal x to the power of negative 3. Okay? And what about this one while we're at it? C. Surely you can see that 1 over x to the power of negative 2 is going to equal, get the x upstairs, and we just reverse the sign of the negative to positive. Okay? So 1 over x to the power of negative 2 in fact is the same as x squared. Okay, this one's quite messy, and in reality you probably wouldn't have to differentiate an expression like this, but it's good practice all the same. So what I'd be doing firstly is getting rid of the, or not so much getting rid of as making separate the negative 3/4 and just timesing it by 1 over the third root of x to the power of negative 1/4. Okay, now what do I do next? Well, the idea now is to convert it from surd form to index form. Now when you remember that that's giving you the power, that's giving you the root, remember from our example before, power and root, this is just going to equal x to the power of negative 1/4 over 3. Okay, so all that's an index, negative 1/4 over 3. Okay, let's continue it over here. So, we've got this equaling a negative 3/4 times. Now, you've got to remember that 1/4 divided by a 3 is going to equal 1/12, isn't it? So we've got 1 over x raised to the power of negative 1/12. Alright, I'm getting there. Now that's equal to negative 3/4 times. Now remember, we can bring this x upstairs. All we do is reverse the sign of the index. So it's x to the power of positive 1/12. And putting it all together, we get equals negative 3x to the power of 1/12 over 4. Alright, you have a go at these ones and press pause, and when you're ready to have a look at the answers, press play again. Alright, number 1. That's easy. All you've got to do is bring x upstairs and reverse the sign of the index. Okay? Question 2, just as easy. Bring x upstairs and change the sign of the exponent or the index. Okay? Question 3, not quite so easy. We'd have to say that that is equal to negative 3 over 2. Now, be careful here, because when there's no number here in front of the radical sign, we assume it means square root. Okay? So, power root. That means we can write it as x to the power of 3 over 2. And what do I do now? Well, I just bring the x and with its exponent upstairs. So it's equal to negative 3x to the, but I've got to change the sign, of course, negative 3 on 2 over 2. And that's the final answer. Okay, have a look at, now try these ones. Okay, 3 times the square root of x. Well, that's just equal to 3 times x to the power of a half. Okay, that's a very handy fact to know, that x to the square root of x is just equal to x to the power of a half, because that occurs a lot in mathematics. Alright, question 5. Let's have a look at it. Very, very similar stuff going on here, except we've got negative 1 over 4 raised to the power of a half. Okay, so you can take that x to the power of a half upstairs as long as you change the sign of the exponent. So it's equal to minus 1 x to the power of negative a half over 4. And what you don't need in your answer is the negative 1 there. So that would be your final answer there. These ones are a bit unusual looking, but we do see these a lot in later calculus. Number 6 is best thought of in this way. If you've got the square root of something, it's the same as having that thing raised to the power of a half, isn't it? Alright, so that would be your first step. Now, to get all this upstairs, all we do is we change the exponent. So it's equal to minus, we don't need the 1 now, x plus 2 raised to the power of negative a half. And we'll learn rules that enable us to differentiate that soon. What about number 7? A little bit similar, really. What we're going to say is that that's equal to 3x, and we are going to put it over x squared plus 3, all raised to the power of a half. And once again, I just take the denominator upstairs, and I can do that as long as I change the sign of the exponent. So it's equal to 3x bracket x squared plus 3 raised to the power of negative 1 over 2. Okay, and we'll learn rules that enable us to differentiate expressions like that reasonably shortly.